Shear and moment. Shear and moment are internal forces on the beam that will be used when we will be designing this beam with respect to bending and respect to the shear failure. Okay, so it is very important for us to know or locate the maximum shear and the maximum moment that is for us to ensure our design at that certain section. Okay, so for here we'll discuss how to draw the shear and moment diagram, and after this we'll discuss how to locate the maximum values of shear and moments. That is the most important thing here, to locate and to get the maximum values of moment and our shear. Okay, so imagine a beam that is loaded with this W here. Okay, so sa shear and moment, we'll be considering 2 points or a segment by segment. We can use the equation method or the area diagram. Okay, so imagine this beam, we will be cutting it at this portion, and then the shear and moment will be exposed. This can be solved by equilibrium. So another segment here where the load is included na, of course, another equation can be formed here, because may dagdag na load na tayo. And another segment, another equation dyan. Okay? So actually, shear and moment diagram is the curve, curve of how the shear and the moment changes at any segments. Parang curve lang siya. Okay, so considering a differential element here, dx. Okay, so that will be approximately W yung ating load. Magiging rectangular siya, because of a very small strip. This can be considered as rectangular. Okay, now at these faces we will be exposing the shear and moment. Okay, so this is our shear here, this is the moment, and on the other side may abrupt or may change of shear yan dito. So V plus change of shear, same sa moment, because nagkaroon tayo ng a change in distance. Okay, now in this figure we can create a relation. By equilibrium, we can just say that that is our equation, and simplifying this one, we can create this relationship. The change in shear is equals to the negative of integral W dx, or that is the change in shear between 2 points in the beam is equals to the area of the load diagram between that 2 points. Now similarly, if we will cross multiply that dx dito, it will create the slope, dv over dx. That one. So the slope of the shear curve at any point is equal to the negative distributive load. That one. Now, when we are talking about moment here, we can say that this moment minus the m plus dm is equals to v times dx approximately. Now, simplifying things there, we can use this relationship. The change in moment is equals to the integral of v dx. Okay, so generally that is change in moment between 2 points in the beam is equals to the area of the shear diagram between that points. This is considered the area of the shear diagram, the integral of v dx. Now again, we will cross multiply our dx here, then it will create the slope, and that slope is the curve. The slope on the curve in the moment diagram is equals to the shear at the same point. Okay, so these are the principles that is important, in drawing the shear and moment diagram. Okay, so these are design conventions. So imagine a beam that will be bending upward because of the bending moment. So that is the positive bending. If we are looking to the left section, then positive bending is clockwise rotation. If we're looking to the the right section, then the positive bending is counterclockwise. But I want you to just understand this one. Pag pataas yung bending, then that is positive bending. No? Otherwise, if baliktad yung bending natin, like this one, that should be the negative bending. Okay? Pa-downward yung bend natin. Now, for shear naman, if the shear forces rotate the beam clockwise, then that is positive shear. Then, vice versa, that will be negative shear. Pag counterclockwise yung rotation natin. Okay, so commonly sa shear diagram, of course, we will be looking at the left section. So the positive for moment is clockwise. Then for shear, the positive is upward. Okay, titingin naman tayo always sa left section when drawing the shear and moment diagram. Okay, let's have an example. So first of all, we should calculate the reactions, no, of B and C. So as you can see, the support at B is pin. So theoretically may horizontal reaction yan. But as you can see in the loading, wala tayong horizontal external force. That's why I will just simplify this one, vertical reactions. Okay? At 1. So by summation of moment about C, then we can solve our RB. Okay? Just follow the solution. Then summation of moment about B, we can solve our RC. Okay, so actually you can use summation of forces when calculating RC, but I suggest summation of moment talaga. Then checking na lang yung summation of forces. Okay? For checking purposes na lang. Now, let's draw the shear and moment diagram. Okay. So, we will do here the equation method and the area method, no, simultaneously. So in equation method, ika-cut natin siya segment per segment kung saan may abrupt change in load. So unahin natin tong segment AB, that one. Okay, so of course may shear and moment dyan, no, considering this distance x, variable x. Now, our shear equation, as you can see here, by equilibrium, V is just negative 10. Okay? So, that's why, constant yung shear natin from here up to point B. From here up to point B. Walang load dyan. No? Now, the moment equation naman, as you can see this one, that should be negative 10 times distance x. Okay? That is for segment AB. Now, we will plot the shear here. It will start, of course, to 0. From 0. No? Then, it will have an abrupt change of shear. That will be negative 10. So, it is going down. Negative 10. Now, from this segment up to this segment, there is no load here. No? Walang load dito. That means, constant yung shear dito. Or straight lang siya. Shear diagram. Or by referring to our equation, walang change in shear dyan between these 2 points. Huh? That's why constant yan to 10. That is our shear area dito. Okay, shear diagram. For moment naman, of course, it will start from 0. Then, as you can see in the moment equation, that is negative 10x. Now, this is a first degree curve. That means it is an equation of the line. Okay, so it will be a straight line, no? And the magnitude at this point, at point B, is just negative 10. Yung x natin, gawin nating 1.5. Kaya that is negative 15. Okay. Now, this is a first degree curve. Okay, as you can see here. Because that is an equation of a line. Or by just referring to this shear, if this is 0, then this will be first degree curve. Okay, this is a 0 degree curve dito kasi horizontal siya. Now, from the principle, if we are to calculate the area of the shear diagram, This is what we call the change in moment between 2 points. Diba, the area under the shear diagram is the change in moment between 2 points. So that means ito yung change niya dito, or that is negative 15. Okay, now let's move to another segment. This segment na tayo. So andito na tayo nag-cut. Now the shear equation here, as you can see, we will be including this reaction RB na, no? So that will be plus 23.75. That is upward shear, no? Now for moment naman, that will be plus 23.75 times x minus 1.5. Plus yung sign natin dito since it will bend the beam at this portion upward. Okay? Yan yung tatandaan natin. Itong shear naman, it will rotate clockwise. Kaya plus yan. Okay, now, considering this shear, it will have an abrupt change muna ng 23.75. From here, from negative 10 plus 23.75, then it will give us 13.75. Abrupt change yan, no? Diretso sa straight line. Then, from here, from point B to this point, there is no load here. That means constant yung shear natin. Okay? And that is our shear diagram. Now, for the moment equation naman, okay, from this point to that point, it will create from negative 15, or just substitute the value of x here, 1.5 plus 2, or x is 3.5. It will give us 12.5. Okay, substitute the value of x as 3.5 up to this point. It will give us 12.5. And again, as you can see in the equation, the value of x is in first degree, or the equation is in first degree. That means it is still a line, equation of a line. Okay, so connecting these 2 points from here up to that point, yan yung straight line natin. Okay, and that is still first degree. Okay, now another important thing here, yung gagamitin natin yung area method, or yung principle na nagawa natin kanina. This area here, that one, is just equals to the abrupt change in moment between these 2 points, point B to that point. Okay, so the area here is just 2 times 13.75 square lang, rectangle, no? So that 27.5 is just the abrupt change. Ito yun. Okay, we can use the equation, or we can use the principle. No? Negative 15 plus the abrupt change 27.5. That is positive, no? Because that is a positive area. So plus 27.5, then it will give us 12.5 at this point. Okay, pwedeng yung equation method yung gamitin natin, or pwede rin yung area method. Now, another segment here, the last segment, that one. So, included na yung uniformly distributive load natin. Okay? Now, for this shear, walang effect yung moment natin dito sa shear diagram. Okay? So, in this case, we will be adding I think this should be minus, no? This should be minus, correct me. Diba? By equating equilibrium here, vertical forces, this should be negative 10 plus 23.75 minus 5 times x minus 3.5. This should be minus, correct me for that. Okay? For the moment naman, that will be this concentrated moment at this point. May effect yan sa moment equation natin. And that is counterclockwise, or ibebend niya yung beam downward. Okay? As you can see, ibebend niya yung beam downward. That's why it is minus 30. Okay? And of course, this 5, or the uniformly distributive load, minus pa rin yan, ibebend niya yung beam downward. So, minus 5 times x minus 3.5 squared over 2. Ito yung moment na idudulot niya dito. Okay? I hope you can follow that one. This distance here is x minus 3.5. no, times the moment arm x minus 3.5 over 2, kaya idiretso natin. Okay? So, take note, this is negative ha, minus yan. Okay, so the shear here, of course, ibabalik niya dito at 1. Okay, using the x here as the total length, substitute mo yung x as the total length, which is 5.5. Again, this is minus, so it will give us 3.75, no? Positive 3.75. And as you can see here, that is a first degree curve. Yung x natin is raised to 1 lang. So that is a first degree curve. And this change nga pala, ito, di ba, from the principle, the change in shear between 2 points is equals to the area of the load dito sa ating beam. So the area of this load is a rectangular load that will be 2 times 5, and that is a negative 10. Okay, negative 10 yan, downward yan. So that means 13.75 minus 10, that will give us 3.75. That is using the principle, no? The area method. Okay, so that is our shear. Now for the moment equation naman, or the moment diagram, substitute the value of x here as 5.5. Then it will give us may abrupt change pa tayo ng shear. Okay? From this position, pag mayroong concentrated moment dyan, then it will make an abrupt change in the moment diagram. So from 12.5 minus 30, that one, ito, then it will give an abrupt change. Then it will give us negative 17.5. No? Then after this one, this is our moment diagram from this segment. That one. Ibabalik niya sa 0 using this equation. Substituting 5 here, no? 5.5 on x, then ibabalik niya yan sa 0. That one. Okay, second degree curve, because as you can see in the equation, may power of 2 na tayo sa value of x natin. Okay, that is an equation of a parabola. And by the way, yung shear dito kanina, nag-fall tayo sa 3.75. Of course, the reaction here is negative 3.75. Ibabalik niya sa 0. Okay? Now, observe this one. Diba sa principle kanina, that the slope under the moment diagram is equals to the shear, no? At that point. So the shear here is constant. Cut this one. So that means the slope of the moment diagram is constant at these 2 points. Kaya straight line yan. The same dito. This shear here is constant. That means that is straight line. Okay? If we are not to use the equation, no? If titingnan lang natin yung ating shear diagram or the diagrams. Now, in this position naman, the shear here is not constant. It is varying, no? So, ganito siya i-plot pag hindi natin to gagamitan. Okay, so, by the way, no? This abrupt change is equals to this area. This area here is trapezoid, no? So, that will be 1/2 of H1, 13.75 plus 3.75 times 2. That will give us 17.5. Positive 17.5. That means, from here, it will have an abrupt change to positive 7.5. Kaya, babalik siya sa 0. Okay? If we are using the principle. Now, ito yung graph natin. How can we know the concavity ng ating graph dito? Okay, so, using the principle, the shear here is positive 13.75. Positive, that means the slope here will be upward. Okay, that means upward slope yan. The tangent at this point, tangent of the curve. Dito naman, the shear here is positive 13.75. So, it will be like this. This one is more steeper because that is 13.75. Ito, medyo pahiga na siya. Okay, 3.75 na lang siya dito. That one. Positive pa rin, going up. If that is a negative shear, then going down yung ating slope. Then, connecting these 2 points, it will have an abrupt, gradual change, no, of the slope. Kaya ganito yun siya. Okay, I hope you understand this one. if this happens na 0 yung shear dito, then the slope here is straight horizontal lang. That means yung concavity natin from 13.75, then it will go steeper dito. Okay? I hope you understand this one. Okay, so let's try this example. Trapezoidal loading naman. Okay. So of course, we should calculate the reactions. So maybe the best option here is to divide the loads into two triangles, na? Then we'll have the resultant of this first triangle dito. So the resultant of that is 1/2 of base 5 times height na 5. So that is 12.5. Now the resultant of this another triangle here is the same, 1/2 of 5 times 10 na yung ating vertical side. So that is 25. Now summation of moment about C to calculate RB, that will be 4RB minus 12.5. Take note that considering this triangle here, that distance here is 2/3 of 5 or 2/3 of the length. Okay, then this one 25 minus multiplied by this distance considering the triangle above is 1/3, no, 1/3 of 5. It will give us 20.83. The summation of moment about B, so ito yung equation natin, no? So 25, unahin natin itong positive moment. 25 times from here up to that point is 2/3 of 5, then minus 1 kasi nag-moment tayo sa B, no? Plus 25, that will be from here up to here is 1/3 of 5, then minus 1. Okay? Then minus RC, 4 RC, then it will give us a 16.67 kilonewtons. Okay, you can check that using summation of equation equilibrium dapat. Okay. Now, the shear and moment equation. That one. Okay, so medyo mahirap-hirap to kasi trapezoid yung loading natin. Okay, unahin natin yung shear. Okay, so by this one, gagamitin natin is the area method na. Okay? Hindi ko na ipapakita yung equation method. So, area method, we need to know or calculate from segment A to B yung area dyan. Area of the load. That one. So, in order for us to calculate this area 1, let's call that area 1, we need to know this one. Okay? This magnitude here. So, this one, this can be modeled by an equation because this is a straight line. Okay, using the linear mode in the calculator, or we can just use the ratio and proportion here, na? But I suggest gamitin na lang natin yung linear mode. Okay, because linear mode will give us this equation of a line. So that will be X and Y. The Y represents W. That one. Okay? So, referring to this origin, gagawin nating origin yung left side, of course. Okay? So, from X is 0, yung Y natin is 5. Then, from X is 5, yung Y natin is 10. So, I hope you can see this in your calculator, no? That is in mode function. Okay, so, ipakita ko lang siguro. Mode stat, no? Mode stat 3, then linear 2, line or linear 1. So 0, input ko lang lahat, 0, 5, then 5 and 10. Okay, now after this, kukunin natin yung constant, arbitrary constant A and B. Okay, so that will be CA lang, ups, then saan ba yun? 8, na? Then kunin natin yung A, that is in 1. Actually, correct ba? Okay, let me just check mode 3, 2. When X is 0, 5 and 10. Okay, so i-cancel ko lang. Then, apps, 8, then 1. 5 yung value niya. 5 yung value ng A natin. Okay, so store na lang natin siya sa A para hindi na tayo ma-confuse mamaya, no? Then, yung B, so apps regression 8, then kunin si B, and the value is 1. So, store ko lang siya sa B. Okay, so we have the values of A and B, then we can define that equation. Okay, y is equals to mx plus b. So, yung y natin represents w. So, the equation is 5 plus x. A is 5, b is 1. So, diretso 5 plus x. Now, after we have the equation of that load, then we can solve this one, this point. So, this point will be when x is 1. So, substitute yung x dyan as 1. So, that is 6 kilonewtons per meter. So, makukuha na natin yung area dyan. Area 1 is just area of the trapezoid, no? So, I will input here negative since that is downward shear, no? So, negative 1/2 of 5 plus 6 times 1. That is negative 5.5. Okay? So, from here, from initially 0 shear, then it gives an abrupt change. Diba, the area is the change in shear between 2 points. So, this one is the negative 5.5. Okay, so, how can we imagine the concavity? So, by principle, the slope of the shear diagram at any point is equals to the load, no, at that point. So, the slope here is equals to the load at this point, 0. So, that is negative 5, yung load natin dyan. Then, the slope here is going down, negative, no? This is negative 5. Then, the slope at this point, to the second point, that is 6, no? And downward, so negative 6. So, that will be going down pa rin. So, ito yung slope natin at end point. So, it will be an abrupt, a gradual change, no? Ito yung concavity natin. And if this is a first degree curve or a line, then this one is second degree curve. Okay? I hope you understand this one. Okay. Now, segment B to C naman. So, we need to calculate this area, na? So, from here, at this point B pala, may abrupt change of shear tayo. Upward shear. So, from negative 5.5 plus 20.83, then it will give us 5.33. Okay, ito yung 20.83 natin dyan. Abrupt change. Negative 5.5 plus 20.83. It will give us 15.33. Okay? Now, considering this area na dito, the second area here, let's call that area 2. Again, that is just a trapezoid. Just follow this one. So, negative pa rin since downward yung forces na yan. So, negative 32. Okay? So, from here, it will have an abrupt change of negative 32. That one. So, 15.33 minus 32, then it will give us negative 16.67. Okay? So, how to know the concavity? Look at the load here. So, the load here is negative 6. That means the slope here is negative 6. Now, that will be going down. Dito naman, that is negative 10. That means, mas steeper yung slope natin dyan. Mas mataas, mas pababa, no? So, negative 10. So, connecting these 2 points here, considering that one. So, may gradual change yan, no? Yung slope natin. And if this is the first degree curve, then this one is second degree curve. Okay. So, from here, okay, of course, ibabalik yan by negative 16.67 plus positive shear upward. So, ibabalik yan to 0. Okay, I hope you understand paano natin ginawa to. So, this is our shear diagram. Okay. Now, moving to the moment diagram. Okay, so as you can see, we need to know these areas. Okay, so we cannot directly say that this one is a spandrel, no? Spandrel of a using the formula spandrel of a parabola. Hindi natin madediretso yan kasi hindi ito yung kumbaga vertex ng ating parabola. Hindi natin magagamit yan automatically. Okay. So, imagine this one. Ito yung total length ng ating beam. Okay, i-disregard muna natin yung ating mga reaction dyan. So, pro-project ko yan dyan. Gagawin ko siyang triangle. Okay? So, this one, masosolve natin tong distance na to using this equation. Okay? Kailan magiging 0 yung ating W? That is when gawin natin 0 yung W, then yung X natin magiging negative 5. Okay? So, anyway, hindi naman talaga magmamatter yung sign dito. Okay, so gagawin ko to. Ito yung technique dito. Project natin. Okay? So, considering na buo yung triangle natin dyan. Okay? Got this one. So, the moment here, because of that whole triangle, the moment diagram, that will be the area of this load. So, 1/2 of 10 times 10. Ano yung value na yan? That will be 50. Okay, disregard muna natin yung mga sign dito. Okay, papakita ko ano talaga yung nangyari dito sa shear diagram. That will be 50. So, ito yung slope niya, negative 10. Dito yung slope natin at this point is 0. That's why horizontal lang yung ating slope dyan. So, from 0 slope, may gradual change of the slope until umabot siya ng negative 10. Okay? So, actually, this diagrams here, itong curve na to, this one, and this one, continuation lang yan ng ating parabola. Okay? Now, from here, ito yung point na yan, dito. This one. Okay? This one is this one. Mahirap kasi sang is-calculate yung area dito pag hindi natin to ma-imagine. Okay? Okay, so this one here, the 0 here, is ito yon, that one. Now, this point naman, we have divided this one as 1 meters and 4 meters here. Okay? So, this point is ito yan. Okay, klaro? This point is ito. That one. Okay, let me call that one as Y1 and Y sub 2. So, this area pala, this area 3 is ito yun. Okay? So, calling that as Y1 and Y2. Okay. So, to calculate this one, gagamitin natin yung SPP. Ito kasi yung gagawin natin to calculate this area. So, this one is a spandrel of a parabola. This whole thing dito. Okay? So, if that is spandrel parabola, the formula of the area is 1/3 of base times height. Okay, 1/3 of base, this total base here, times height. Then, i-minus natin itong maliit na spandrel. Then, i-minus natin itong rectangle. Yan yung gagawin natin. Okay? Hindi natin magagamit yung 1/3 of base times height automatically dito. Kasi hindi ito yung origin natin ng ating spandrel. This is not the origin of the spandrel. The origin of the spandrel is when the slope is 0. Which is dito yun. Okay? So, by SPP, y sub 1 over 5 squared, that one, is equals to the known point that is 50 over total length 10 squared. And we have the value of y sub 1, 12.5. Y sub 2 naman, y sub 2 over 6 squared is equals to 50 over 10 squared. So we have the value of y sub 2, 18. Okay, so i-substitute na lang natin doon. That one. Okay, so i-calculate natin yung area 3. Okay, so area 3 would be this one, this spandrel, itong malaki-laking spandrel na to, 1/3 of 6 times height na 18, minus maliit na spandrel dito, so 1/3 of 5 times 12.5, then i-minus natin tong rectangle na to, so minus 1 times 12.5. Okay, I hope you got this one. So it will give us negative 8 over 3. Okay, now illocate naman natin yung area 4 and area 5 dito. Okay, so area 4 and area 5, it is somewhere here, no? Nahati siya dito. That one. And let's call that Y3 na lang muna. And ito yung area 4 natin. Nasa labas siya. Okay, as you can see, dito siya at this portion. Ito. Ito yung area 4 natin. Parang na-move siya dito. Okay, I hope you got this one. Itong area 5, ito naman yan. Okay, to locate area 5 here, ito yun. Okay, so how can we calculate the area 4? This one. Okay, so we can just consider this rectangle here. This rectangle minus itong maliit na portion dito. Then ito yung ating this one, the area 4. So, i-calculate natin to. We need this value, y sub 3. Okay, so y sub 3, as you can see, that is just 50. Okay, look at this one, ha? 50 minus antong dimension na to. From here up to that point. Ito yun. Here up to that point, which is 16.67. Okay, so medyo ma-analyze talaga to. Kasi medyo mahirap yung approach natin basta trapezoidal. Okay, so that's 1. Y sub 3, 33.33, and it will give us that one. Okay, so let me call this one, ito nasa ibaba, as area 6. Okay, area 6. So how can we calculate that area 6 para makuha natin yung area 4? So let me call this one as Z. Wala pa tayong value dito pala, no? From here up to that point. So that can be solved by SPP again. So that will be saan ba tong 13.33? This should be 33.33. Okay? Naging 13.33. 33.33 siya. This one, y over x squared. So x is 6 from here up to that point plus z, no, is equals to 50 over the total and 10 squared. And here we have the value of z, 2.16. Okay? That one. So, calculate ko na yung this point. Ito, yung area 6 natin. So, that area 6 is equals to, consider this whole spandrel here, that will be 1/3 of the total base from here up to that point. That will be 6 plus 2.16 times the height here is 33.33. And it will give us, minus pa pala. Area 6 yung kukunin natin. So, i-minus pa natin to. Yung spandrel na to. So, minus 1/3 of 6 times 18. And that is 54.66. Okay, so, calculating the area 4, which is this one, that will be this rectangle here. So, that will be 2.16 times the height of 33.33 minus area 6, which is this one. So, we have the value of area 4. Okay, so medyo mahirap na. Okay, ganito talaga siya. Now, take note that the value of this distance here is 4 minus 2.16, or that is 1.84. So, how can we calculate this area 5? That one. So, again, the same drill. The whole spandrel minus the spandrel here, that one. Okay, minus this rectangle. Okay, whole spandrel, ito yon. Then the spandrel here, 1/3 of base, which is 6 plus 2.16 times height na 33.33. Then minus the rectangle, 1.84 times 33.33. And that is our area 5. Okay, so these are our areas. So we can plot na our moment diagram. And actually, we can check if these are correct. So, i-add natin yan lahat. Negative 8 over 3 plus 17.33 plus negative 14.68. That will give us approximately equals to 0. Okay, kasi nag-round off na tayo dito. Okay, so, diretso na tayo. Dito, the area 3 is negative 8 over 3. No? That means, in the moment diagram, may abrupt change tayo na negative. The change in moment between the 2 points, if 8 over 3 is 2.67. So, negative 2.67. Okay? So, the slope here, that is negative 5.5. So, downward, no? The slope here is the shear dito. Ano yung shear natin dito? That is 0. That means, horizontal lang yung slope. Okay, from horizontal slope until umabot sa slope nito, ito yung concavity ng ating moment diagram. And that is third degree curve na. This is second degree curve, then this is third degree curve. Okay. Okay, from this point naman to that point, what is the area? So, yung area natin is 17.33. So, may abrupt change tayo dyan. Na? Yung abrupt change natin is yung area 4, no? Which is 17.33. So, negative 2.67 plus the area 4, then it is 14.66 approximately. Okay, so the concavity naman. So, the shear at this point, that is 15, positive 15.33, then that will be upward, positive man, no? Positive 15.33. The shear at this point is 0. That means horizontal lang yung slope dyan. Okay? So, connecting this slope, and it will have a gradual change of slope. So, ganito yan. From 0 until umabot sa 15.33. And of course, this is a third degree curve because that is second degree yung ating shear. Okay? Now, from this point up to that point naman, last segment, so it will give us a change in moment, no? Or the change in moment is just equals to the area. So that will be the area 5. So that area 5 is negative 14.68. So 14.66 minus area 5 approximately equals to 0 lang din. Na? Okay, equals to 0 kasi nag-round off kasi tayo sa values. So the slope here, of course, 0 yan. Ito pa rin. And the slope here is negative 16.67. So that is going downward. Okay? Medyo steep na siya. So connecting the curve here, this would be our curve. Okay? So that is third degree curve pa rin. And this is our moment diagram. Okay? So medyo mahaba-haba talaga, no? Lalong-lalo na pag i-discuss. But if kayo na yung mag-solve, of course, mas mapapaikli natin yung oras. Okay? So after all, guys, we are always after to the critical values of shear and moment. Kumbaga, hahanapin natin yung maximum shear and moment because yan yung gagamitin sa design. So actually, hindi na tayo obliged na dumaan pa sa shear and moment diagram if we know how to locate the maximum shear and the maximum moment. Now, observe this one that when the shear is 0, the moment is maximum. Okay, relatively maximum. Yan siya. So, ito yung magiging one principle natin para hindi na tayo dumaan sa shear and moment diagram. Okay, look at this one. Integration nga lang siya. But, hindi naman tayo yung gagawa ng integral, no? Hindi tayo magsosolve ng integral. Yung calcu yung magsosolve. Okay, using that one, we will consider a differential element, dx. That one, dx, okay? So, the load here, that one, may concentrated load tayo dyan. Tawagin natin R, no? That is just W times dx. Okay, considering W natin, parang naging rectangular siya. Diba? Concentrated load, that is load, area of the load, W dx. Okay? So, consider this one as our distance x from the origin. So, yung sa kabila, okay. So, dito naman, that will be 5 minus, no, the total length, okay, 5 minus x nga. Okay? Okay, so ipakita muna natin, isolve natin yung reaction using this one. Okay, so disregard na yung load natin, yung uniformly distributed load. Ito na. Okay, so summation of moment about C, that will be 4 of RB minus this load. Okay, that load is 5x dx, 5 plus x dx. Moment arm is 5 minus x equals to 0. Then, i-transpose natin tong whole term na to, which is this one. Then, i-integrate natin. I-factor out lang natin yung 4. Okay? That will be 1/4. Then, integral from 0 to 5. Yan yung limits natin. Okay? So, using the calculator, hindi na natin kailangan gawin yan. And, it will give us this one. Okay? Same as sa C, kukunin natin yung C, summation of moment about C, that will be this one. 5 plus x dx, yung load na yan, a moment arm is x minus 1, that is the moment arm, then minus 4 of RC. Then rearrange, okay? The same lang, the limits from 0 to 5, it will give us 16.67. The same lang dito. Okay, I hope you appreciate the integral, no? Kasi napakalaking gamit ng integral. Now, isolve natin yung maximum shear and moment at B. Yan naman yung pinaka-importante when designing, no? The maximum positive and negative shear and moment. So dito may maximum negative shear and maximum positive moment and negative moment dito, no? So ito yung magiging itsura niyan. Differential strip pa rin. Dito na yung differential strip natin. I-cut natin at that portion. Okay. Of course, we have the shear here and we have the moment. Okay, considering equilibrium, shear at B, summation of forces vertical. So the vertical forces here, that will be downward load, which is 5 plus x dx, that one, minus shear at B. So we will consider immediately to the left pa. Hindi pa natin i-consider yung ating 20.83. Okay, so transpose this term, yung BB natin, then integrate natin from 0 until 1. That one. Okay, I hope you understand that one. So it will give us negative 5.5 kilonewtons. And if you observe sa shear diagram natin, this is the maximum, the shear, negative shear at point B. Now, another point here is immediately to the right. That means, i-consider na natin yung load natin na 20.83. So, from this, the same lang, but nag-add lang tayo ng 20.83 upward, then, transpose, integrate lang ito, then i-add natin 20.83. So, ito yung positive shear natin at B. If you remember, kanina. Okay, look at na lang. I-replay nyo yung video. The same to ng value natin sa positive at shear at B. Okay? So, the moment naman, this moment at B, we will take moment about B. Of course. Okay, summation of moment about B. So, ito yung mas gamit natin yung positive shear at B. Mga maximum critical values yung kino-consider talaga natin. Okay, for shear, hint lang, for shear, that will always act at the supports. So, dito, supports, hindi pa natin alam if ito ba yung maximum shear or ito. Kasi naka-overhang yan. Okay, i-check natin yan. Which is, ito, nakuha natin. Okay, moment at B, summation of moment about this point should be 0. And that will be, okay, so this load, so counterclockwise moment, 5 plus x dx, got to be going down. Moment arm is 1 minus x. Okay, so minus mb, that will be counterclockwise, equals to 0. Then, transpose yung mb, so integrate natin of course from 0 until 1 lang. Okay, then it will give us the value of negative 2.67 kilonewtons meter. And this is the value of the moment at B, if you remember, in the shear diagram, shear and moment diagram. Okay, now, this is the maximum negative moment. I-locate natin yung maximum positive moment by considering a distance na lang, na. Again, this is still our x, no, from the concentrated load. Then, at maximum moment, shear is 0, as you observed kanina. So, let me just call this one as distance A. Okay? So, ito yung principle. Maximum moment, shear is 0. This V should be 0. So, we can calculate the A if we know this principle. By summation of forces vertical, that one, so that will be 5 plus x, minus 5 plus x, plus 20.83 minus shear V, then equate to 0. But take note, for maximum moment, this shear here should be 0. So that's why, ito yung mangyayari. I-transpose na lang natin yung 20.83 sa kabila muna. Okay, then integrate natin to. Then the limits is from 0 until A. Okay? I hope you understand that one. So, counting integration lang. This is just a power rule, no? So, integrate natin yan. That will be 5 plus x squared over n plus 1. So, squared over 2 pa rin dito. Then, the limits is from 0 to a is equals to okay, so we just canceled out the negative sign dito, no? Na they are both negative dito. So, i-cancel ko na lang dito. Dito, kaya naging positive 20.83. So, the limits is, ganito yung gagawin natin. Okay? 5 plus x. So, substitute x as a. Then, minus the same equation. 5 plus, substitute x as 0 over 2. Then, it will give us the value of a. 3.16. That is from point A. No? Here up to that point. So, if you remember kanina, the distance from point B to the maximum moment is 2.16. So, minus 1, yung 3.16, it will give us 2.16. So, correct, na? The same pala. If we know the distance A na, then, pwede na natin makuha yung maximum moment dyan. By summation of moment about this point, na? So, the moment here, okay, so, that will be, unahin natin itong force na to. So, 5 plus x dx, the moment arm, of course, that will be 3.16 minus x. Ito to, a minus x. Diba? Mag-moment tayo dito. So, 3.16, itong a minus x, which is, x is that one, variable yung x. Okay? Then, this 20.83 will cause clockwise moment. So, positive. The moment arm is a minus 1 or 3.16 minus 1. Of course, this moment will be our maximum minus maximum moment counterclockwise. Okay, so i-transpose natin yung mmax, then integrate natin para makuha natin yung value. No? So, integral of the same equation dito, then the limits is from 0 until 3.16 lang, of course, dito. Okay? And ito yung value ng moment natin. 14.7. O nakita nyo kanina, that is 14.66 na. So, medyo may discrepancy talaga because of the values na nag-round off tayo. Okay? So, this is the answer. I hope you appreciate the integral, no, dito, because napakalaking gamit talaga. Kahit anong curve ito, kahit anong equation ng curve na yan, makukuha natin by using integral. Okay? So, that's it for today.